All right, so let's look at this activity, page 538. Let's see. Donovan, will you read the first part?
Basketball player plays like 8% of the free throws that he takes. We think he might shoot faster. The test claim will ask him to shoot free throws using the reasoning principle that at the first website.
Yeah, that's good. Okay. All right, so we've got like Josh Brinkerhoff or somebody claiming they could make like 80% of their free throws, right? I don't know. I hear he's pretty good. So, Abby, will you read number 2? Oh, thanks. Cece, will you read number 2?
Steffi averaged 25 shots. 6-2. How many of the 25 shots did the player make?
All right. Okay, let me do that first. So we're going to change this number of shots to 25. And we're going to watch the guy. Yep.
Where are his arms?
Wow, this person's pretty good.
He's also a big guy. Way off to the left.
So started good, right? But ended up with 84%. Still, that's better than he claimed. All right. Delaney, what's the next part say? All right, so I'm doing another 25 here. Okay, it's dropping, right? Now we're down to 76%. So let's try. What do you guys think? Is this person probably close to what they're saying? You guys don't think so? Let's try a new shooter. Different person. This is me, yeah. Yeah, it's rough. Ooh. Yikes. All right. So we may have convincing evidence, right, in our sample that maybe I'm lying, right, that really my score might not be 80%. So we're going to start proving or disproving a claim like that, okay? So first of all, what's a significance test? That's what we're learning. You might want to write this definition down. A formal procedure for using observed data to decide between two competing claims, also called hypotheses. So we're always going to have two competing claims. We're going to do a random sample, and then we're going to use our observed data, our random sample, to decide which hypothesis we think is true. We either believe the 80% or we don't believe the 80%. All right. So when you state your hypotheses, you're going to state two things. The null hypothesis, which is the H naught, okay, and the alternate or alternative, I would say alternate, same thing, alternative hypothesis, HA. All right, the claim we weigh evidence against in a statistical test is called the null hypothesis. So the null hypothesis for the shooting one that we just looked at is P equals 0.8, right? It's our 80%. Josh Brinkerhoff claims he makes 80% of his free throws. So that's the null hypothesis, is the claim, the original claim, okay? The alternative hypothesis is that he makes less than 80%. Maybe we don't really believe it, so we're going to test it and find out, okay? So to help you remember the null hypothesis, it's the Null hypothesis. All right. So H naught is null, HA is alternative. What does null have to do with? It's the one that they claim at the beginning. So it's the boring one, just to help you remember. It's the 80% versus the exciting. Maybe he's not really stating that correctly. Okay, we can also have, like, let's say that our null hypothesis, well, in this case, it's the 80%, right? Proportion of free throws is 80%. The alternative hypothesis has a couple choices here. We could have an alternative hypothesis where maybe we really believe Josh is way better and he makes way more than 80%. That's one option. Maybe we believe he makes less than 80%. He's exaggerating, okay? These are each called one-tailed or one-sided alternative hypotheses, okay? If you're not sure, usually the problem is going to lead you in one direction, right? Where maybe we think the player's exaggerating, so we're going to go with the less than as our test, okay? But if they don't lead you in one direction, you have to just say, well, maybe it's just not 80%. Okay, that is two-tailed or two-sided. If it's not 80, it could be either like way above it or way less than that. So your alternate hypothesis is either one-tailed, you're saying it's less than, or it's greater than, or it's two-tailed, it's neither of those. Okay. Juicy pineapples. All right. At the Hawaii Pineapple Company, managers are interested in the size of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one field was 31 ounces. So now we're talking about means instead of proportions. A different irrigation system was installed in the field after the growing season. So managers are wondering how this change will affect the mean weight of pineapples grown in the field this year. Problem: state appropriate hypotheses for performing a significance test. Be sure to define the parameter of interest. All right, so we're no longer using p's in this problem. What are we using? Mu, right? We're using mu. So first we have to state what mu is. And we want to find, so mu is the mean weight of all pineapples grown in the field this year. So we need a null hypothesis, all right? So a null hypothesis is always H naught, okay? And our null hypothesis is the 31, okay? We're going to assume the mean weight is 31. Okay, then we have our alternative hypothesis. So HA. This problem did not lead us in either direction, okay? It didn't necessarily say a better irrigation system or a worse irrigation system. So we don't know if we're going to get larger pineapples or not. So our alternate hypothesis is just not 31, which is two-tailed. So some side notes. The hypothesis should express the hopes or suspicions we have before we see the data. So it's cheating to look at the data and then form your alternate hypothesis, obviously. So let's say we knew that we went ahead and did the study and we got almost 32 ounces for the 50 pineapples. You cannot go back and change your alternative hypothesis. Oh, now that I know, I'm going to go with greater than. All right? Don't do that. So you have to do it based on what the problem says, and if they don't give you a clear direction, just say not that number. Okay? What? I wouldn't recommend it. All right. Hypotheses always refer to a population. So that's another thing that's important. When we write the null and the alternate hypothesis, we're always talking about the population. Don't ever use a p hat or an x bar. In other words, use a p and a mu, right? So use the parameter of interest, not the sample information, okay? Let's try a real problem. Describe the parameter of interest, so when we state what mu or p is, and for part B, state appropriate hypotheses for a significance test. So we want the null hypothesis and the alternate hypothesis, and that's it. So according to the website, sleepdeprivation.com, 85% of teens are getting less than 8 hours of sleep a night. Janny wonders whether this result holds in her large high school. She asks a simple random sample of 100 students at the school how much sleep they get on a typical night. In all, 75 of the responders said less than 8 hours. All right, so our P, how would you guys define your P? What is P? David S., what do you think? Like that, okay. And then we need a null hypothesis. Chelsea, what do you think the null hypothesis is? Yes, but you can't just say 85, right? What symbol do we use? Yep. So P equals 0.85 would be our null hypothesis. And we don't know this yet, okay? You can't look at this when you write your alternate hypothesis. This one, I know you guys would suspect less, but it doesn't say that either way. So you actually just want to say P is not 0.85 for this one. Okay? So P, there's our H naught, 0.85. HA, P is not 0.85. Okay? And that's all you got to do. Oh, I don't want to show that. All right. As part of its 2010 census marketing campaign, the U.S. Census Bureau advertised 10 questions, 10 minutes, that's all it takes, on the census form itself. We read, the U.S. Census Bureau estimates that for the average household, this form will take about 10 minutes to complete, including the time for reviewing the instructions and answers. We suspect that the actual time it takes to complete the form may be longer than advertised. So they're giving you the suspicion, all right? So first of all, are we talking about mu or P? Mu, we're talking about an average, okay? So that'd be mu. And David O., how would you define mu? Good. Okay, and Donovan, what would you say for the null hypothesis? What'd you say? Okay, and you have to have a symbol. Mu equals 10. Good. And they did give us a suspicion, right? That it may be longer. So Chelsea, what would be your alternate hypothesis? Yes. Good job. All right, so mu is the true mean amount of time it takes to complete the census. H naught, HA. Everybody good? Pretty easy today? Yes. No, don't. Because you defined it here. Yeah. Okay.